We're going to take what we did at the end of last week with the numbers and just kind of get a little more practice with classifying them, putting them in correct sections. One of the main things we need to be able to do is differentiate between rational and irrational numbers. That'll show up on your unit test, that'll show up on your check-in, that'll show up on your EOG. So, who thinks they can come up here and sort all of those correctly? Between rational and irrational. All of them. Yeah, give it a try. All right, rational numbers. Rational numbers are numbers that can be written as fractions. Irrational numbers cannot be written as fractions. So for irrational numbers, that includes decimals that keep going without repeating. That's when you see those dots at the end. That means it keeps going. Pi is an example of a decimal that keeps going without repeating. Square roots, we don't know the answer to. We don't know a square root of 2. It's not a whole number. Square root of 75, not a whole number. That makes them irrational. So those four there are irrational numbers. For the rational numbers, like I said, it's numbers you can write as a fraction. So that definitely includes fractions. If it includes fractions, it's going to include the mixed numbers also. Decimals that repeat or decimals that terminate, that stop, as rational numbers. And then square roots you know the answer to, or should know the answer to. What's the square root of 25? 5. What's the negative square root of 9? Negative 3. If it's got the negative in front, that's what that's meaning. Okay? So that'd be negative 3. Everybody kind of follow on that? Any questions? Not so bad, right? So when we do that, if we have to group them, if we have to sort them, you might have to identify which one's rational, which one's irrational. I'm going to show you a couple different problem types that go with that as well. So one of the types of problems you could see something like this. It's asking which of the following is an example of a rational number between 7 and 8. All right, so we are looking for a rational number. So if we look at A, is B a rational number? Of 53. But we don't know it. That makes it an irrational number. So even though it fits that part, that's between 7 and 8, it's not rational. Mixed numbers, fractions, so they're A and C are both rational. Yeah. Is between 7 and 8. 7 with a fraction is between 7 and 8. So that would make D the correct answer. A and C are the ones that fit both. Okay? Everybody kind of follow? That's one way these questions can kind of look. This maybe not so much on the EOG, because it's asking why or why not, but this is something we need to be able to answer as well. Rachel states that negative 5.5 is an integer because it is negative. G, correct. Who can tell me, is she correct? Which we did on Friday, integers were on the left side. So yeah, all those were rational numbers. Would negative 5.5 be an integer? No. Corey, why not? Why do you think no? You said no. No. All right, so if you remember from Friday, in the very middle, we had natural numbers. Natural numbers were our counting numbers, our positive counting numbers, 1, 2, 3, 4, and on, right? After our natural numbers, we had whole numbers. What whole numbers added was 0, okay? So that'd be 0, 1, 2, 3, 4, all included there. After the whole numbers is where integers came. Integers include 0, like we had, our 1, 2, 3, our counting numbers, but it also includes the negatives of the counting numbers. So that's negative whole numbers that are included on integers. Is that a negative whole number? No, it's got a decimal. So the next one further out was just the rational numbers. That included anything that had decimals or fractions or anything like that, whether they're positive or negative. So that would just be a rational number. Okay, it wouldn't be an integers. Any questions on that one? All right, go ahead. Give us a try. I want an example of each of the following, if possible. Not all of them are necessarily possible. For that one on the top left, who thinks they can give me an irrational number with a value greater than 10? Nevaeh? No, 11's not irrational. Whole numbers aren't irrational. What type of numbers are irrational? Not just decimals. Not fractions. Irrational numbers are numbers that cannot be written as fractions. So that's decimals that keep going without repeating. That's square roots we don't know. Pi is irrational, but it's not greater than 10. Whole numbers are not irrational. No. That's less than 10. Yeah. Decimals that don't terminate. They keep going without repeating. Has to be greater than 10, so let's just go with 12.345, and I put some dots at the end. That is an irrational number. It's a decimal that keeps going without repeating. It's greater than 12 is greater than 10. That would be a correct answer there. What is 10 squared? What's 10 squared? 10 squared. 100, yeah. So 10 squared is 100. So if we're looking for a square root we don't know an answer to, and it's got to be greater than 10, it's got to be square root of something greater than 100. Y'all, I could put square root of 101. We don't know that, do we? That's an irrational number. Any square root we don't know, that's going to be above 10. So I could do 101, I could do 102, 103, 104. You get that idea? Just can't do 100, that's 10. Can't do 121, that's 11. Can't do 144, that's 12. You get what I'm saying? A square root we don't know is an irrational number. Okay? On the top right, asked about an integer between -5 and -6. What did we say integers were earlier? Those are the real numbers. Negative numbers. Whole numbers, right? What whole numbers between -5 and -6? There isn't one. So this is one that's not possible. All right? The reason it's not possible, integers are positive or negative whole numbers. Okay? So we're looking at -5 is an integer, -6 is an integer, but in between them, there is no integer. It's only fractions and decimals. Okay? On the bottom left here, a whole number less than 0. This one is not possible. All right? Like Quan said, there's not a whole number less than 0. Natural numbers came first. Those were your counting numbers. Whole numbers were next. That included 0 and the natural numbers. That doesn't include negative numbers, so that one's not possible. Last one there, rational number represented by a square root. Nope. Yeah, so we need a square root here. Square root of 16, that works. Y'all, for it to be a rational number represented by a square root, it's a square root that we know. Square root, it needs to have a square root. Square root of 16 is 4. We know that one.